Hello and welcome to lesson 8.6, solving linear systems using elimination, part B. All right, so good job on the homework quiz earlier. Please remember, if you have questions, to reach out during the lesson or during office hours. I'm not getting hardly any questions from anyone in Compacted, so if you need help, you gotta let me know, okay? So I'm here, and reach out. We will most likely be taking a summative assessment on this the week after we come back from spring break, so probably that Thursday. So just know that that's going to be coming. All right, well, let's get to it. So let's see, I'm going to share my screen. You should have your 8.6 notes out. There's only 2 examples that we're going to do, so it shouldn't take too long. So basically last time when we did elimination, we had to put them into standard form, line them up, and either add them or subtract them. I don't know if as you did the homework, you noticed that you made any errors with subtraction. Sometimes that happens. The way I'm going to teach today's lesson is that we only add them together. What's going to be different though is that our coefficients aren't going to automatically cancel. So what we're going to have to do is we're going to have to manipulate the entire equation so that the coefficients do cancel. And I'm going to teach it so we only do addition. So I don't recommend subtraction. It's up to you, but that's the easiest way. And after 15 years of teaching it, I find that kids make less mistakes. So it's just a big recommendation. Yeah, I highly recommend it. So, okay, so we're solving it, systems with elimination, part B. Step 1's exactly the same. We're going to write equations in standard form. So again, it's just an easy way to line them up. Standard form, I'm going to abbreviate it because I didn't make the blank long enough. We're going to place them on top of each other so all the X's and all the Y's line up. All right, so if you look at example 1, that's already been done. I don't want to make it tricky. Okay, so step 2, here's the new thing. We are going to, I just noticed that it says step 2 and then it says step 2. All right, so you get to do a double. So we are going to multiply one or both equations by something so that X or Y have opposite coefficients. So in the last lesson, you either had like 2x, and then in the next equation, you'd have negative 2x. And then if you add them together, the x's cancel. Or you had something like 5y and negative 5y. If you add them together, something cancels. Well, if you look at these 2 equations over here, none of the coefficients are opposites, and none of the coefficients are the same. So we have to manipulate one or both equations so that that is true. That's the only way we can eliminate. So I can either look at my X coefficients, and I can turn both of those into 6 and negative 6, which, okay, that's kind of nice because one of them is already a 6. Or I could look at my Y coefficients, and I can manipulate those so they turn into 15 and negative 15. Neither one is the wrong answer, but there is one that's a little more efficient. So I would recommend turning the X coefficients. I'd recommend eliminating X and turning the coefficients so one is a 6, one is a negative 6. So what I'm going to do is I'm going to multiply this second equation by a negative 3. So I'm just going to put a negative 3 out in front like that. And now I'm just going to do the distributive property. So I'm going to distribute the negative 3 to the 2x, which gives me negative 6x. Put a little arrow here. I'm going to distribute the negative 3 to the 3y, which gives me negative 9y. And then don't forget, a lot of people forget this part. I'm going to also distribute the negative 3 across the equal sign to the 5. So you can do whatever you want to equations as long as you do the same thing to all the parts or all the terms of an equation. If I didn't multiply that 5 by negative 3, I would have changed the entire problem. Okay, so that's step 2. Step 3 would be to add the 2 equations together so one variable is eliminated and follow the steps from the last lesson. So we've got opposites, so I'm going to line them up like we practiced last time. And I'm going to put my, where's my equation? I can't see it. I'm going to put my 6x plus 5y equals 19 on the top. And I'm going to put my new equation that I manipulated, negative 6x minus 9y equals negative 15 on the bottom. And then I put a plus sign here. So again, I always go for opposites. I could have multiplied everything by 3 and then subtracted, but again, people make more errors, so I'm recommending not to do that. Okay, my x's cancel. 5 minus 9 is negative 4y. 19 minus 15 is 4. Divide both sides by negative 1. Y is negative 1. All right, now I'm going to find my x. Remember, you've got to plug it back into either one of the original equations. So don't plug it into one that you manipulated just in case you made a mistake. Sometimes a mistake cancels out another mistake, kind of like a negative times a negative is a positive. So I'm going to plug it back into the second original equation just because the numbers are smaller. So I get 2x plus 3 times negative 1 equals 5. So I get 2x minus 3 equals 5. And I add 3 to both sides, so 2x equals 8, and x is 4. So notice I'm skipping the steps where I add things to both sides. That's fine, but what I did notice on the test is some people just moved it to the other side and didn't actually undo it. So just a reminder, to move something to the other side, you actually have to do the opposite. So if you are getting those wrong, I would recommend showing the step you did. Again, you don't have to, but just make sure you don't miss them for little simple things like that. Okay, highly recommended, not required. I would check your solution. Okay, this is how you're going to get 100% on the assessment. You're not going to miss anything, whether you do green or blue. So my check is 6 times 4 plus 5 times negative 1 equal to 19. That's the question of the day. Is 24 minus 5 equal to 19? It sure is. Sweet, that one works. And then I'm going to do my second one is 2 times 4 plus 3 times negative 1 equal to 5. I can just see that one by looking. It does. Therefore, the solution to the system is the ordered pair 4 comma negative 1. And that is where the two lines intersect on the coordinate plane. All right, good job. Okay, let's do one more example where we have to manipulate both equations. And notice in this one, they're also not in standard form. So just remember, get them in standard form. I'm going to subtract 3x from both sides here, minus 3x. What I like to do is I like to, no, what do I like to do? No, I'm just going to write it. I'm going to write them to the side. I was just trying to think about my organization. I get 4x plus 5y equals 35. And now I have my new equation, negative 3x plus 2y equals negative 9. So be careful. There's that negative with the 9. Okay, so I can either turn my coefficients of x into 12 and negative 12, or my coefficients of y into 10 and negative 10. So what I would do is I'd probably look at the other numbers in the problem to say, if I want to turn this into 12 and negative 12, I'd have to multiply by 3. And if I wanted to turn this into, the second one into 10 and negative 10, I'd have to multiply by 2. I prefer to multiply the top equation by 2 just because 35 is kind of big. So that's what I'm going to do. Again, you could totally eliminate x in the first part and get the exact same answer as long as you didn't make any mathematical errors. Okay, so here's what I'm going to do. Let's get rid of those circles. I'm going to turn my y coefficients into 10 and negative 10. And maybe you would say, I don't want to multiply by a negative 2. So maybe you would have stuck with the 12s. It's totally up to you and the x coefficient. So I'm going to go with the y's. I'm going to multiply this first equation by negative 2. And I like to draw a little arrow to show what it becomes, just to keep track of my work. So I get negative 8x minus 10y equals negative 70. I could have just as easily multiplied the second equation by negative 5. There's 4 ways to do this problem. Okay, so I'm going to multiply the second equation by 5. 5 times negative 3x is negative 15x. 5 times 2 is 10y. And 5 times negative 9 is negative 45. Okay, I have opposites,